civil engineering student. This being my first video, I would like to inform the overview of all the upcoming videos. I would be covering civil engineering topics, and amongst that, first in this month or two, structural analysis will be covered. So topics covered would be accordingly. You can have an overlook on that. So let's start our first topic, that is TMT. In this, I would be covering just one question in a video so that it is not monotonous, and also the question that would be covered in the next video will be shown to you so that you can have an idea of the next video. So let's get started. First of all, just have an overview of the definition or the explanation of three-moment theorem, TMT. Theoretical part will not be covered as such, as it is already available, but only the numerical parts will be covered. So the main points for this TMT is that for application of TMT, 3 supports are mandatory. If there are 2 supports on the beam, then TMT will not be applicable. Number of applying TMT, that means you are applying the TMT for many of times, will be always equal to number of unknowns, and this is the formula. So let's get started with our first numerical. So first of all, there would be 3 diagrams. First diagram is called as action diagram, second diagram is called as reaction diagram, and the addition of action diagram and reaction diagram will be a final bending moment diagram. So first of all, as we know that when there is a uniformly distributed load and when there is a point load, in uniformly distributed load we always find that there is a semicircle found, and in point load we always find that there is a triangle found. As it is symmetrical, so we would be going with the formula as WL by 8 for the uniformly distributed load, WL square by 8, and for point load we would be going by WL by 4. So by calculating it, we would be getting as W means there is 40 into 16, that is 4 square, and upon 8, and here we would be going as WL by 4, that is 100 into 6 upon 4. So here the answer would be 150 after calculation, and here it would be 80. Now the number of unknowns, how to find the number of unknowns. So here first of all we would be getting here MA equals to 0. Why? The reason behind that is there are no supports prior to the A support, therefore it will be 0. Here MB will be unknown, that is there is some value of MB because prior to and after B support there is a support, so and MC it would be 0. Same reason as that of A. So now applying the number of unknowns equal to number of applying TMT. So here number of unknown is 1, that is MB. So TMT applied will be only one time. So now applying the TMT formula, that is MA L1 upon I1 plus 2MB L2 upon I2 plus L1 upon I1 plus MC L2 upon I2 equals to minus x1 upon L1 upon I1 minus 6A2 x2 L2 upon I2. So here first we would be summarizing the things like where the how much L1 value is, how much L2 value is. So first of all, what is L1 value? That is the beam, first beam span is AB. So the length of that is 4 meter. I1 is I. L2, that is span BC, the length is 6 meter overall, and I2 is 2I. Now since it is a symmetrical diagram, that is having the equal distances, x1 will be 2, that is half of 4, and x2 will be 3 meter, since total is 6 meter and it is on equal distance, that is load is placed on equal distance, so it would be 3 meter. Now putting the data, following data in equation 1, that would be since MA is 0, so this whole value will be 0, and since MC is 0, this whole value will be 0. Now 2 MB is equal into L2, that is 6 upon 2I plus 4 upon I equals to minus 6 into A1. Now the problem here stands is from where we would be getting the A1 and A2 value. Now I already told you as that here, since it is a symmetrical, here we would be getting a semicircle and here we would be getting as a triangle. Now the value we found was 80 and 150. So here it would be 80 and this would be 150, and this is a positive, and I already told you that it is an action diagram. So the area would be 2 by 3 A into B, that is A1 would be 2 by 3, A means the length, that is 4, and the height, that is 80. So the answer would be here as 213.37, and A2 would be similarly half into base is here 6 meter and height is here 150. So the answer would be 450. Now putting these values in the equation, minus 6 into A1 is 213.37 into x1 is 2 upon L1 is 4 into I minus 6 into A2 is 450 into x2 is 3 upon L2 is 6, and here this is this is the problem we face. I2 we always put by mistake as I, but here it's present as 2I, so note it as 2I. So the equation would here be this. After solving this, we would be getting as 2 MB into 7 is equals to minus 639.99 minus 675, that is minus 1314.99 here. So the MB value is minus 93.927. You can always check or verify it by the calculator. So now we have to find the second diagram, that is the second diagram here would be reaction diagram. Now how is the reaction diagram? The value we found as MB, that was our unknown. So the reaction diagram would be MB equals to 93.927, and this reaction diagram is always negative. Reaction diagram is always negative. As I already told you that the final bending moment diagram is action diagram plus the reaction diagram. So here it is 80 and here it is 150. So now we would here draw the reaction diagram, that is 93.927. Now this is the area, nullified area, since it is overlapping each other. Since it being negative, here it would be negative, and this is positive and positive, and this is a final bending moment diagram. So that's it. TMT procedure is over. You can always ask doubt. I would be providing my contact number, so if any doubt you can always contact me. And yeah, of course the next video would be having a numerical that would be a bit difficult than this, and the next numerical is this, so that you can have an idea what the next video would be. So thank you, and do subscribe and like. Keep learning. Thank you.